Okay, so it's week 7, and I'm going to go ahead and kick off the discussion board. And I'll just apologize for not being a little more on top of the teaching. As you know, I'm struggling just to keep the program afloat here. But anyway, commodity chemicals. And so what I'm hoping to do, I'm just going to kick it off with this discussion. So do a little research and see what kind of commodity chemicals are available from your favorite biomass product. Like, so for example, let me give you a couple. Oh wait, here's mine. Oops, not that one. So Blue Marble Biomaterials, let me just show you those guys. They're here in town. In fact, Blue Marble, they've hired a lot of our graduates. So if you're looking for a cool place to work and into the bioenergy thing, here they are. I'm just going to click on products. This thing changes all the time. I don't think they list too many specifics, but food grade, kosher, renewable feedstocks, allergen free. Here's the this is key, and then green chemistry is another one.
Is this pretty well known? This 12 steps of green chemistry?
I'm not 100% efficient with it, but I think what it is just looking at sustainability through a biomass lens rather than it's mainly physical. So obviously the first one, large scale preventing waste, atom economy. I mean that's pretty intense. Yeah. And just yesterday we were over at St. Pat's trying to see if we can't help them with their waste stream, and you're realizing like a lot of weird crap comes out of there. But I would love, and this has been my dream, and I've got drawings in my notebook, but just to have a large scale mass spectrometer. So whatever combustion products or pyrolysis products come off, like every single atom, step number 2, gets accounted for. Yeah. It's all got a value. You just got to concentrate, right? Less hazardous, safety, fewer solvents, energy efficiency, renewable. Yeah, derivatives. I'm not 100% sure on what derivatives are, but it's just an extra step. Catalyst, typically this is some type of heavy metal that reacts but doesn't enter the products. So that's something to take a look at. Anyway, Blue Marble Biomaterials a few years ago was refining Thujone, and they were doing it because it is it's a toxin. As you can read here, it's actually banned in a lot of substances because it might in fact be a neurotoxin. But as a topical agent, it's used to remove warts and skin tags like compound W might. So it's an acid. And again, I'm not going to claim to be the world's greatest chemist here, but I just can't help but think that this really tight carbon bond might not be part of where the reaction is occurring. So if there's a lot of energy stored when you're bending those bonds like that, and it could be that this thing, well, it degrades, it reacts. I mean, that's what chemicals do. It's not going to sit there and just stay Thujone forever. It's going to interact with whatever biomaterials there are in the skin and basically break them down.
It could be because of that odd carbon bond.
I think so.
It has those unique qualities.
Yeah. So Arbavita, These guys were getting it, so obviously, there's also in junipers. If I'm not mistaken, they were getting their Thujone out of cedar that was just coming off of the lubric experimental forest. So it's got some kind of, aura to it about being a cannabinoid or a hallucinogen, but apparently that's not necessarily the case. Yeah, I was hearing though that some of the workers who were exposed to too much of it, it sounds like it is alcohol soluble rather than water soluble, and if you look, yeah, so that's basically, see you've got these methanes kind of hanging off the side. That gives you an indication that it's going to be alcohol soluble rather than water. If you had a bunch of OHs hanging off the side, then it would be more water soluble. But the fact that you've got these CH3s, that's going to be an alcohol soluble. And the significance of these different bonds, we're just showing that the bonds. So these dark black guys are sort of coming towards you. This dotted line is going away. So in this case, all three are coming towards us. This is basically just the mirror image of it. Gotcha. It's the mirror image. Just it's the same molecule. It's just like a hand. They both have 5 fingers, but they look just mirror images of the same molecule, same chemistry.
Is that the isometric qualities, the different shapes, so they fit in different receptors?
Well, yeah, and here's the other issue with that. If you go out and look at let's just go look at the amino acids really quickly. Usually it's referred to as chirality. I already gave my money. Geometric property of some molecules and ions, mirror image. So it's the same exact molecule, it's just mirror image. And now, so for example, most amino acids are considered to be right-handed. And the deal there is that all of these chemical reactions have to occur with molecules that have the same handedness. So for example, DNA, if I'm not mistaken, is a right-handed helix, and when the proteins interact with it, they have to fit. So just like shaking hands, it doesn't. I mean, I guess you can shake hands like this, but it doesn't make as much sense. It's not as efficient. Neither is this. So you kind of need 2 right hands in order to shake hands, and that's why this chirality. So at its fundamental basis, chemistry really does come down to geometry. Yeah.
Electron physics and stuff.
Yeah. So anyway, that's what these bonds are indicating. In this case, you've got all 3 coming towards you, all 3 going away. So they're mirror images. In this case, this is just called beta Thujone, with 2 of the bonds coming towards and 1 going away, and there's just the mirror image of that. So 4 separate chimeras, and it would be my guess that only 1, maybe 2 of these are going to actually interact with human metabolism. So I'll kick it off with that. Oops. Thujone, copy. Week 7 discussion. Blue marble, And so what they're doing, if you take a look at this little bottle here, there might be gallons of Thujone sitting there in a ton of, well, maybe not gallons, but maybe a gallon of Thujone sitting there in a ton of wood. It's just a matter of cooking it in such a way that you don't burn it, because that molecule will burn just like any other hydrocarbon. So what Blue Marble is doing is sort of stewing it and literally refining it, just like an oil refinery refines oil. You give it some heat, the lighter stuff goes to the top, the heavier stuff comes to the bottom. At some point, Thujone assumes its proper density, and you siphon it off, and then you can sell it. A bottle like this might be $100. So what was just scrap wood is now a few tens of dollars per gram once it's reached the research grade.
So it's just really scaling the cost of extraction to meet the market value of
Mm-hmm.
selling it out, something like that.
Yeah. And I think that falls in line with these 12 these basics of green chemistry. You probably could go in and manufacture the stuff from scrap, but it's already there. It's already there, and just with a little bit of heat and nudging. So renewable feedstocks, and they're using catalysts instead of stoichiometric reagents, and also avoiding the synthesis. It doesn't have to be synthesized. It's already sitting there in nature. Okay, so I'll kick off week 7 with that. Submit that guy. And let me get back in here. There's also Pi Day. Let's check that out. Pi Day is in 4 days. If you have kids, Zulu time. Oh, I gotta check that out. Zulu time.
Yeah, it's based on Greenwich Mean Time or whatever. I think it's like 3 hours ahead of us.
Yeah? Is Zulu a...
So it's just, it's kind of like universal time, military time.
Just call it.
But it's not Greenwich Mean Time?
I don't think so, but I think it has something to do with Greenwich Mean Time. I looked it up today.
Right, something like this. Last year, and his alternative fuels when he had one for, was it Avogadro's number?
Oh,
The same kind of thing.
623?
Yeah, totally.
Okay. I don't know what Zulu time is.
I think for us, we're at close to around 9:15.
So, okay, so let's see here. So it's 11. It's 11 here. That means it's 1 on the East Coast, and Greenwich is 5 hours ahead. So
0, 0, 0.
is it not just Greenwich?
It's Greenwich Mean Time.
Oh, it is.
It's a military slang. Z for Zulu, 0 time. Or Z for 0, Zulu time. It's here.
Okay, so it's a time zone. Other time zones. Okay. So if it's 3, what's he say here? Okay, so if it's 3 a.m. there, it's 8 a.m. on the East Coast, and it's 11, so it's 11:14 a.m. here. Okay.
Yeah, that makes sense.
No, so that's doable. Everyone's wide awake at 11:14. Okay.
Yeah, I think we have to post around like 9 o'clock. Maybe it's a little bit or something.
I think it's 11.
Could be 11.
Well, no, 3 plus 5 is 8. No, it's 10. 10:15. 10:15. Mountain time. There you go. Okay. Well, what do you guys feel like working on? I'm going to give you one little update though about Japan. You know, I was over there with as part of the Mansfield Center delegation on health and energy, and so there were a couple other energy guys. One was the former governor of Wyoming, Jim Geringer. He's actually talking up his GIS systems a lot. He now works for a company called Esri, so they're doing a lot of geospatial mapping of a lot of different systems. And it's basically for making cities run more efficiently. But my take on it is that if we were to look and do something similar to what Solar City will do, where they'll do a Google Earth maps, three-dimensional of where the rooftops are, they can actually do an assessment of your house without doing a site visit. So they're able to come in ahead of time. I would love to take that another step further and, you know, look about optimizing the renewable energy grid, both from energy flowing in through a PV cell, but also waste products flowing out. Downtown Tokyo, there are no trash cans. There's none. And there's no garbage on the ground either. I mean, I might have seen 3 cigarette butts the whole time I was there, and maybe a plastic bottle, but that was it. And what I did see, and this has some relevance to the bioenergy course, is that you walk into the mall, and for the entire mall, there's a garbage can about, you know, this big, maybe holds 2-3 gallons, and one side said flammable, the other side said inflammable. And so I think what they're doing there with their waste stream is, one is just, you know, paper and maybe some compost, maybe you burn it, maybe you just bury it. And the other one was, you know, your metals, you know, if you've got your coffee can or juice can or whatever. So pretty impressive. And then I also had the opportunity I gave, we did a little discussion board with Dr. Abraham Kim, who's the director of the Mansfield Center, former Governor Jim Geringer, who's doing some geospatial, but also into coal, you know, Wyoming's a big coal exporter, and then with Bill Whitsitt, who was formerly with Devon Energy. So they've done a lot of advanced hydraulic fracturing. So the 4 of us, Abraham Kim, Dr. Abraham Kim, former Governor Geringer, Dr. Bill Whitsitt, he's got a PhD, I think, in communications from Columbia, and then myself, we just did a little discussion board in this really cool studio. It would be great to get some energy tech folks over. Let me show you, right? City, Japan, Grape City Home. They were in a neat little spot. Oh, this is what else I want to tell you. Very relevant to bioenergy. And I don't know if we're going to get to see any of their artwork, but you walk in there and they've got these giant, gorgeous chunks of wood, just, you know, like heartwood, driftwood, and I'm like, oh my gosh, these things they're beautiful. And just talking with the owners, like, well, yeah, one of the brothers was touring the Pacific Northwest, comes across this barn, there's some kid there with all these giant chunks of wood, and one of the brothers walks up and says, hey, I'll take those 5 pieces for, you know, how's $5,000 sound? So these are huge, they're like the size of trucks, right? And he's like, really? He's like, yeah, that's some really nice wood you got there. He goes, in fact, I'm looking around your shop, because he just inherited it from his father. So yeah, I think you got about 100 grand worth of precious wood here. He's like, oh, really? I think I just burned about $500,000 worth. Yeah. So, yeah. So, Grape City.
1 minute's trash.
Right. We were there, and anyway, that's where we had our forum. I don't know why it's not coming up there, but anyway, here's a little thing. There's their logo. A lot of software services. So they're making animations for children's software, mainly teaching children to speak English. Let's see what else is here. Foundation. Yeah, I just want to get some pictures. Maybe they'll show some of the inside. Yeah, so here's their campus. Oh, there we go.
Nice.
Yeah, so we got, actually got to touch that table, and this just came out of, some old barn in the Pacific Northwest, and gorgeous old wood. So another thing we're trying to collaborate with Grape City on is the education. So you can see they're making software for kids, and make a connection with the island nation of Samoa. So we've currently got a bid in to do photovoltaics in Samoa. The last time we tried something in an island nation, Antigua, it fell through because of this oil cartel that owned it, but I think it's because the local population was just sort of ignorant about the fact that there's much cheaper, greener energy tech out there. So we're hoping to avoid that fate by using Grape City Studios to do a little bit of promotion of green energy on Samoa to the school children.
That's a great idea.
We'll see how it works, yeah. Okay. So that happened in Japan. The other thing that was a lot of fun is we're sitting around the table, again, with Geringer and Whitsitt and our contingency from Montana, with the head of policy for the country of Japan. And as you know, when the tsunami hit on March 11th, 2011, they went from something like 60% nuclear to 0. So suddenly now they've got to have some kind of energy source to keep the lights on. So they look to actually the U.S. and our natural gas supply. So now they've got a lot of turbines running. But when they were looking around the table, they're really looking for renewable energy solutions. And so what I was given the opportunity to do was say, hey, we've got a lot of dead biomass in Montana. We've got a lot of plastic garbage, like you can't even believe, and Patrick Brown, who's going to come in and lecture here in a week. So what I would really love to do would be able to take his commercial venture and get a contract going with Japan. So, and the energy density of their pellets is comparable, if not superior, to that of coal. And I got to show you one other thing while I'm thinking about it, because it's unbelievable. Let me just back out of the bioenergy course for a second. If you guys want to take this and run with it, please do, because my eyes popped out of my head last night when I was looking at this. Here, let's just take a look. I'm gonna drop into ETEC 214, Energy Storage and Distribution. I'm going to hop down to week 7, Learning Unit 7. I think it's in here. Pacific Gas and Electric. Okay, they were talking about running the grid. Coal. Okay, check this out. Cost of coal for one of the assignment problems. Okay, one of these kids is not like the other.
Wow.
Yeah, wow.
That's really crazy.
Graphically,
Yeah.
Western Rail, right through Zootown, every day. I mean, can someone just tell me we're not giving our coal away?
It's insane. It's insane.
Like, you know, I've always heard that there were capitalists in Montana. Now I'm not so sure.
That's not even the kind of capitalism. I mean, because these really are.
Well, you know, it's like, gosh, is it inferior quality?
I've heard it's.
Well, it's okay. So it's 8,000 BTUs, but it's not 3,000 BTUs.
No, that's a significant.
It's
So is that?
it's low sulfur. It's not that much lower in energy. What is going? There's some bizarro price fixing going on that I cannot wrap my head around.
That's what it is. I mean, that's all going to China for the most part.
Yeah.
So somebody's getting a kickback to keep the cars running. You know?
I don't know. Like, how can that just be hanging out there and no one's doing anything about it?
It's somebody. You know, there's got to be a group of investors behind that company that could look at this and say, "What in the hell are you doing?" that may be like negligible as far as a corporate entity goes. You know, pricing their stuff that much lower. That's crazy, man.
It is bizarro. I've never seen anything like that. I don't understand it. Someone needs to explain it to me. I mean, I know a little bit about economics, but wouldn't just a normal like third grader see that and be scratches?
If it's, you know, there's a third less BTUs, maybe it's a third less cost, you know, but not.
Yeah, no.
Not like that.
Yeah.
That's insane. And it's downsides.
Yeah. Okay, so that's bioenergy, not in action. Okay. All right, let's just take a break here and then we'll get into 244.